Hi everyone, my name is Pradyumn Kejriwal and today we will discuss the solution to the 24th problem from the CP sheet by TLE Eliminators under the rating of 1400. So let's begin. So I have my sheet right here and I'll open it, the problem. So it is called the number of products. You are given a sequence A1, A2 up to AN consisting of n non-zero integers. You have to calculate the following two values. The number of pairs of indices L, R such that AL plus 1 up to AR is negative, and the number of pairs of indices L, R such that AL plus 1 up to AR is positive. Okay, so it is pretty simple. The problem is pretty simple. It is saying that we have to count, like we have been given an array A, let's say of size n, A1, A2 up to AN, such that its product, we have to count the number of subarrays, that is the number of pairs of indices L, R such that the product of subarray, that is AL into AL plus 1 up to AR, it is negative. So first value is this, and second value such that the product is positive. So AL plus 1 up to AR is positive. So to count these two values, that how many are negative and how many are positive, right? So the samples are like quite big, so I'll make my own sample. So let's say the array is given to be 1, -2 and 3, right? And we have to find out the number of pairs of indices L, R, that is the number of subarrays L in this array, such that its product is positive and negative. So let us count the positive ones first. Okay, so this subarray is positive, so 1. Then this subarray is negative, so nothing. This subarray is also negative. Okay, then we have basically this subarray, it is negative. Then this subarray, it is also negative, right? And finally this subarray, it is positive. So 1 plus 1, which is 2. So we have two subarrays which are positive. And what about negative ones? We can just subtract 2 from the total number of subarrays, right? Because we are guaranteed that there are no elements which are 0 in this array. So the product is either negative or positive. It is never 0, right? So if we want to find out the negative ones, we can just subtract it from the total number of subarrays in this array, which is basically n into n plus 1 by 2 for an n length array. So here it is 6. So we can do 6 minus 2, which is equal to 4, right? So in this case the answer would be 4, 2, because they are asking for negative and positive, right? So similarly you can try to find the answer for these tests as well by yourself. Okay, and the constraints on n are like up to 2e5, right? So since we know that in one test we can do up to 10 to the power 8 operations per second, like approximately. So that's why we cannot do O of n square in this, because n is given to be up to 2e5 and n square will go up to 10 to the power like 4 into 10 to the power 10, so which is much more than this 10 to the power 8 limit. But you can try to do O of n or O of n log n, and they will fit inside your time limit. Okay, so yeah, you can just pause the video right now and try it by yourself. Okay, so I am assuming that you have tried the problem by yourself and you want a solution. Okay, so to solve this problem, just think of what is asked. Okay, so what is asked is the number of subarrays L, R such that the product is positive. The product is positive and also negative also, but let's just find out the positive ones for now, and we will subtract it from n into n plus 1 by 2, like the positive ones, and we'll get the number of negative product subarrays, right? So let's just focus on counting the positive ones right now. Okay, so when is, like if I ask you a question, that if I give you an array A1, A2 up to AN, and if I give you a subarray L to R, then how will you check that is its product positive or negative? Okay, so first method would be just to multiply all of those. So AL plus 1 up to AR, just multiply all of these and check whether it is positive or negative. So but that is complicated unnecessarily, like you don't need to just do that. Instead what you can do is just see that how many negative elements are there in this range. Like in this L to R range, how many elements are negative? Okay, and of course if there are even number of negative elements, if there are even number of negative elements, then of course the product is positive, right? And if there are odd numbers of negative elements, then the product is negative, right? Like of course, like if we have even number of negative elements, then those minus signs will cancel out, and finally the product will remain positive. And if we have odd number of them, then one minus sign will remain, and therefore we'll have negative product, right? So it is pretty simple. This observation is pretty simple. But now let me ask you one more question. That what if I give you this array and I give you q queries of L comma R? Okay, I give you q queries of L comma R, and I ask you that is the product from L comma R of this array negative or positive, right? Then what will you do? Like how will you answer those queries? Because right now you are just iterating over this range L comma R and counting the number of negative values. So that is like O of n per query if you do it like this. So how do you actually do it? So the way to do that would just be through prefix sums, right? Like how? Because basically you have to count the number of negative elements in the range L comma R, right? So what you can do is just count the number of elements. Let's say the number of negative elements is stored in P of I. Like let's say that P of I stores the number of negative elements, in the range 0 to I minus 1. Okay, so my P of I stores the number of negative elements in the range 0 to I minus 1, and like P of 0 is 0. Okay, so if you want to find out that in this range L to R how many elements are negative, so what you can just do is write this L to R range as 0 to R minus 0 to L minus 1. So like you get it, right? Like you can call this range L to R as 0 to R and take that away, like take this 0 to L minus 1 away from that. So basically the idea of prefix sums, right? So if you have stored P of I, which is the number of negative elements in each prefix, right, then you can simply use that and just find out the answer. So the number of negative elements in this 0 to R range is what? It is just P of R plus 1, right? And this 0 to L minus 1 is P of L. So for any indices L to R, if I give you, you can just calculate this prefix sum, or I mean you can just calculate this difference, and that will give you the number of negative elements, right? And if it is odd, then you can say that the product is negative, and if it is even, then you can say that the product is positive, right? But what is the point of all this? Like why did I ask you this? Because in the problem we don't have to do this, right? In the problem we just have to count the number of subarrays having negative and positive sum. So how do we like use this thing in our problem? So it is actually quite useful. This idea of prefix sums is actually quite useful in this problem. So what we have to do is, I'll just again reiterate the problem, that count the number of pairs L to R such that the product is positive. That is, we have to count the number of pairs L to R such that the P of R plus 1 minus P of L is even. Okay, so our problem actually boils down to this, that we have to count the number of L comma R such that my P of R plus 1 minus P of L is even, right? So when will it be even? It will be even either if both are even. Like, one case is that both P of R plus 1 and P of L are even, and another case is that both R plus 1 and P of L are odd, right? So in both of these cases, their difference will be even, and the product and in that range will be positive, right? So how do we actually calculate that? Now there are multiple ways to calculate that, but what I did in this problem is that I just found out that for a given R, like basically for a given R, or let's say for a fixed R, how many L's are there? Okay, so like what I am doing is that for a given R, how many L's are there such that this P of R plus 1 minus P of L is even. Okay, so for this R, if this P of R plus 1 is, let's say, odd, then I'll have to count that how many L's are there such that L is less than equal to R. Obviously L is less than equal to R, and this P of L is odd. So basically I have to count the number of odd values of P of L, or basically I have to count the number of values of L such that PL is odd and L is less than equal to R. And if this P of R plus 1 is even, then I just have to count the number of values of L such that P of L is even, right? So the main idea here is that why don't we just keep a count of both of these? Like, let us just keep a count of odd and even. So idea here is keep a count of number of L's such that P of L is odd and also even. Like, keep two counters. So the first counter will store that for how many L's P of L is odd, and the second counter will store that for how many L this P of L is even. Okay, and let's say when we want to count for a particular R, so if that R, like if that P of R is odd, then we will just add this counter to our answer, this odd counter, because all of those L's for which P of L is odd are valid, right? So we'll add this counter to our answer, and if P of R is even, then we'll add all of those L's, that is, we'll add the counter of even to our answer, because all of those L's for which P of L is even are valid. So like, I'll just give an example, okay, to make you understand better. So let's say I have 1 minus 2, 3 and minus 4, right? So basically the prefix sum would be what? I have defined it like this, that the first index is 0, then second one is that in this prefix how many negative are there, so 0, then third element is this prefix, so 1, fourth element is this, so 1, and fifth element is this, so 2, right? Now I have to count the number of L and R such that basically they have same parity, right? So first I'll go here. So this can't be R obviously, because this is R. I mean this can't be R plus 1, because this is R plus 1, then where is L? L cannot be anywhere. So I'll start from this index. Okay, so I start from here, and also in my even counter, like I have two counters, even and odd, right? So currently even is 1 and odd is equal to 0. And why is even 1? Because this is there, like to count this index. So since this P of L is even is 1, right? Now let's say R plus 1 is this. So how many L's are there? Like this is even, right? So we have 1 L, So we will add 1 to our answer, right? And also we'll count this one, like we'll just increment the counter of even because this is even. So even becomes 2. Then we come here. So this is odd, but we have no odd here. So there are no valid sub-arrays. So we'll add 0. Like basically we'll add this odd counter and then we'll increment this odd counter. Then we'll come here. We see this is odd. So we'll add the odd counter, right? And also we'll increment it, right? Then we go here. It is even. So we'll add this even, right? And we'll increment this even counter. So it becomes equal to 3. So finally the answer is just 4. That is, there are 4 sub-arrays in this array such that the product is positive, right? And you can verify that also. Like we have this 1 sub-array, 2 sub-array, then this 3 sub-array and the entire 4 sub-array, right? So there are 4 sub-arrays whose product is positive. So that's how you can just calculate the number of sub-arrays whose product is positive and just subtract it from n into n plus 1 by 2. So this will give you the negative, right? So I'll just repeat it one more time very quickly, that we have to count the number of elements, I mean the number of pairs L comma R, such that P of R plus 1 minus P of L is even, right? So what I'm doing is I'm counting that for every R, that for every R how many L's are satisfied, right? So if my P of R plus 1 is odd, then P of L has to be odd. So if my P of R plus 1 is odd, I'll have to count the number of L's such that P of L is odd. And if P of R plus 1 is even, then I'll have to count the number of L's such that P of L is even. So I will just keep maintaining those 2 counters, that for how many L P of L is even and for how many L's P of R is odd. So I'll have 2 counters, and as I iterate over the array for the value of R, I will just add the odd or even counter to my answer, basically denoting that for that particular R plus 1 value how many L values are satisfied. So like if you remember, when we were here the even value was 1, so we added 1 to our answer. So what that means is that for this R plus 1 value there is this 1 L value which is even. So we'll add 1 to our answer because for this value of R I have 1 possible value of L, right? So I will add the answer for all values of R and we'll get the total number of sub-arrays, right? So this is the entire solution, and I'll show the code now. So in my main function I just have the fast IO and I call the solve function, right? Then in solve function I have int n scene n, int arr n, then I take the input, right? Then I have 2 counters, odd and even, okay? And also I am not storing the entire prefix sum, like instead of the entire prefix sum array I am just counting while I am iterating. Like I am not storing all of these values in my memory, but instead I am just storing that where I am, how many negative values have I seen. Like basically if I am here, then I will know that I have 0 negative values till now. If I am here, I know that I have 1. So this is what the cur stores. So cur basically stores the P of I. Like I am not storing the entire prefix sum array, but rather only the value at the current index, right? And also the ans, where I'll keep adding the counters. So now basically this cur stores that is the number of negative elements odd or even, okay? So not really the prefix, I just store the odd or even part, right? So if cur equal to 0, then that means I have seen even number of negative elements, and if cur equal to 1, then that means I have seen odd number of negative elements, right? So I am iterating over the entire array from 0 to n, or 0 to n minus 1. Now if this is a negative element, then I have to flip the cur. That is, if it is 0, then I have to make it 1, If it is 1, I have to make it 0. So I just do cur equals to 1 minus cur. Guys, remember, this cur stores the parity of number of negative elements. Like, not even pi, it basically stores pi mod 2. Okay. So if cur equal to 0, that means currently the pi is even, or p of r plus 1 is even. So we need the number of even l's. So ans plus equals to even. Right. And also then I will increment the even counter because the current one was even. And otherwise ans plus equals to odd, and I'll increment the odd. Right. So finally this ans contains the number of subarrays with positive product. Right. So we'll print the negative and the positive. So negative is just n into n plus 1 by 2 minus ans, and positive is just ans. Right. And the time taken for this approach would be just O of n, because I have just one for loop of O of n, and extra space used is just O of 1 because I have these just 4 variables that I'm storing. Right. So I have done this in O of n time and O of 1 extra space. Right. So yeah, I hope it was pretty clear, and thanks for watching.